A very good evening to all of you. My name is Rahul Kanyal and we have had a discussion about queuing. Yesterday I gave you a context of why do we need to work on queuing, right? And yesterday we took up theory of queuing and we saw a model, right? The simplest model that comes in most of the examinations. A very good evening, Kisna Ram and Mohammed, a very consistent students in YouTube and the app. All right, and if you have not downloaded the app, then you can download the app and get it done through app. Okay, Shadow, a very good evening. All right, then let's get started. Okay, then we have extra 30% off 27 to 29 for courses and green card. All right, it's a wonderful opportunity, and yes, we also have some lucky winners and gifts. Okay, and just okay, let's get started. So can you please try this to the same model that we have discussed yesterday? Okay, yeah, Shubham, it's good to see you. Okay, yeah, good, Shubham, it's good to see you here. All right, chalo, let's do this. So yesterday we have had a discussion about queuing and the theorems, and not the theorems actually. We have had a discussion about waiting time in the queue, length of system, length of queue. Okay, so I'm going to just write them here for you. Okay, so I don't have. Okay, so length of system is nothing but lambda upon mu minus lambda. Length of queue is nothing but lambda square upon mu into mu minus lambda. Okay, waiting time in the system is nothing but ls upon lambda, that is nothing but 1 upon mu minus lambda. All right, and waiting time in the queue is nothing but lq upon lambda. This is what we have been discussing, right? So lambda upon mu into mu minus lambda. Yes, this is what we had discussed. So this is nothing but average number of customers in the system. We also talked about what is the difference between system and a queue. Okay, and this LQ is nothing but average number of customers in the queue. Okay, and this is nothing but waiting time of customer in the system. Okay, and this is nothing but waiting time of a customer in the queue. Is it good? Yes. Okay, now just make sure that you're noting down these formulas, because using these formulas you'll be able to solve many questions in GATE and ESE and other exams. Okay, yeah, Krishnaram, good to see you again. All right, maybe you have shifted to the app. All right, is there any problem in the screening? Is there any problem with the video quality? Yeah, good. So I'm going to take you back. Okay, now what is the probability that a machinist arriving at the tool grip will have to wait? Let's do this. Okay, yeah, so what do you think do we need to calculate with this A option? So before even A, lambda is nothing but average rate of 7 per hour, and mu is nothing but exponentially distributed with a mean of 1 upon 4 minutes, so that is nothing but 1 upon 4 in minutes. Okay, and that is nothing but 4 into 1 upon 60 per hour. Okay, that is nothing but 60 upon 4 per hour. Yes, that equals to 15 per hour, right? Yes, so mu is 15 per hour, right? Good, Shadow. Ankit, yeah. So what do you think do we need to calculate here? What is the probability that a machining arriving at the tool crib will have to wait? Okay, for example, a machinist goes to the tool crib and he waits there. So what is this that we are talking about? So Ankit has already calculated, that's 0.47. But what did you calculate, Ankit? Okay, so just tell me. Okay, fine. So length of Q. Is it length of Q, guys? Do you agree? Mohammed says it's length of Q. So is it length of Q? Come on, come on, come on. So what do you need to calculate is the question. Just think. Don't tell me the answer, just think about it, okay? Channel efficiency, okay. Ankit says it's channel efficiency. What about others? Come on, just think about it. That a machinist goes there and he has to wait, right? There's already a queue out there, right? So what it is asking for is probability that system is busy. System is busy, right? There are already people out there. That is what it's asking for. So what is probability that system is busy? Yeah, so Ankit, you're right. That is system utilization. That's good, okay, good. It's not length of queue, Mohammed, okay? It's not length of queue. Yeah, that's system utilization. All right, as Shubham is trying to tell us. Was it good? Yeah, so what is that? Probability system is busy. Yesterday we have had a talk. Just type in, okay? What? Just type in. Yeah, that is that P0? Rajni says it's P0. Is that P0? That is nothing but lambda upon mu. And what is lambda? Lambda is nothing but 7 and mu is nothing but 15, right? So this is the probability that a machinist arriving at a tool crib will have to wait. Agreed? Exactly, yes. Shubham, you're right. Good as usual, okay? Lambda upon mu. 0.467, okay, whatever that is, okay? Gokul, yeah. And it's really good to see you guys, okay? You just, in queuing theory, what you need to do is just understand the statement. Okay, if you don't understand the statement, then it becomes a bit messy, all right? Okay, let's move to B part. Hello, could you understand this? Just type in I or an I. Just type in I or an I. But yes, if you missed yesterday's video, obviously this thing is not going to work for you. Okay, but still if you want to stick here, you can be here and try to understand, because this is just formula based. Okay, should we proceed? Okay, Mohammed says I, so I'm going to proceed with B. So what do you think the B is? Just try to understand it, guys, okay? Mu is nothing but 15 per hour. So what is average number of machinists at the tool crib? What is that? Can you please tell me what do you need to calculate here? All right, just tell me. Okay, Krishna Ram says yeah. Krishna Ram says length of the system. Okay, Shubham says LS. Okay. Okay, fine. Okay. Chalo. So, any other questions or any other responses? Sorry for that. Yeah, Ankit also says LS. Others, what do you need to calculate? Obviously, yes. So, people are saying it has to be length of the system, that is average number of people, customers or machinists at the system. That's what we need to find here. So, that is nothing but lambda upon mu minus lambda, and lambda is nothing but 7 upon mu minus lambda, 15 minus 7. All right, that's what it is. Okay, 7 upon 8. All right, is that good? Hello? No, Shadow, I won't be taking new topic. Okay, I'll be just discussing few questions here. All right, I'll be discussing few questions here, okay? Yeah. So can you please like the session? Okay, if it's not too much for me to ask, and share it with your friends, all right? That will motivate us to come up with these kind of videos for you guys, okay? Chalo, now the next one. Just think about it. I'm going to give you 5 minutes for this, okay? I'm going to give you 5 minutes for this, and the time starts now. 9:15, I'm going to reveal the answer to you, okay? Made a policy decision that it will install a second crib if a machine had to wait on an average 5 minutes before being served. So what should be additional flow of machinists to the tool crib to justify a second tool crib? Okay, it's a bit tricky, all right? Okay, yeah. So can you please do this? Can you please try this? I'm going to get away from your view. Just think about it and what it is trying to tell us. That's why I keep on saying that, you know, communication is really worth it, okay? English, if you're not able to comprehend what is written in a question, obviously you're going to lose so many marks, right? That's what it is. Okay, additional flow of machinists to justify a second tool crib. So what is that? What do we need to calculate, all right? That's what we are trying to figure out here. Okay? Yeah. Flow of machinists. Now this one is also, you know, additional flow of machinists to the tool crib. Additional flow of machinists. So what is that? Flow. Flow is the tricky word here. All right? Okay, Mohammed, WS is given, he says. Okay, is WS given to us? What is this? 5 minutes. Is this WS? What is this? Guys, what is this? Is this WS? Waiting time in the system, WS. So what is it? Okay, WQ, you are saying. WQ, right? Yeah, that is nothing but waiting time. The Q is given to you 5 minutes. So WQ is given to you as 5 minutes. Just write whatever is given to you. Okay? Write whatever is given to you. When you start writing, you know, many occasions, yeah. Krishna, you're correct. Average waiting time in queue is 3.5 minutes. Yes, I agree. No requirement of second crib. Okay. What is the probability? What is it? Okay. No, there's no requirement, but it says that, you know, what if there's a requirement? Okay, Krishna. Yes, if you're saying that 3.5 minutes, if you calculated it, all right, and it comes out to be 3.5 minutes, but it says that, okay, what if we need a second crib one day, right? So for that, what should be the additional flow of additional flow of machinists, right? So WQ is nothing but, what is WQ? That is lambda upon mu into mu minus lambda, right? So what it is asking for is, I'm going to just write lambda prime here or lambda dash here, okay? So what it's trying to tell us is, okay, fine. So even before that, I'm going to just, what is mu? Mu is nothing but, okay, now this 5 needs to be converted into hours, right? 5 minutes, because lambda and mu we have taken as per hour. The units have to be consistent, right? Okay, so lambda is nothing but 7 per hour and mu is nothing but 15 per hour, right? This is what we wrote. Yeah, so this one has to be converted into hours, so that is nothing but 5 upon 60 hours equals to lambda dash upon mu is going to be the same 15. Okay, 15 minus lambda dash. So can you please find lambda dash? Can you please just do a quick calculation and find lambda dash? Yes. .80. Is that in minute, Mohammed? No, it should not be in minute, right? It should be in per minute. The unit of lambda is in per minute, but here it will be getting it in per hour, right? Is it good? Is it good? These are just formula based questions, okay? These are easy. If you practice them, they become easy, all right? If you go back and practice them, whatever is taught over here, they become easy for you. Okay. Yeah, so can you please tell me what is the value of lambda dash? Quickly, guys. .08, is that it? Or 8.33? Two different answers. Can you please? Yeah, so I'm going to take 8.33. 8.33 per hour, right? Because everything is in hours. Yes? Yes, agreed. So what it means is, if you increase, initially lambda was 7 per hour, all right? If you increase it to 8.33 per hour, then a machinist will have to wait on an average for 5 minutes, because we are increasing the rate, okay? And the flow of machine also tells us about the rate. Okay? So what should be the increase in the flow rate? What should be increase in the flow rate, right? That's what should be additional flow of machinist to the tool crib to justify a second tool. Additional flow of machinist. So what should be it? How much addition should you do to 7 per hour to make it to 8.33 per hour? That's what it is asking, right? So answer is nothing but 8.33 minus 7, that goes to 1.33. This addition you need to do to 7, okay, to make it 8.33, right? That's all. Yeah, so 1.33 per hour is the answer. Is it good? Yes? Is that good? Hello? Do you agree or don't you agree? Do you agree to whatever we discussed, or you have some other thoughts? You can discuss it here, all right? Don't worry, we have lots of time here. Is it good? Yeah, so Mohammed, is it clear? Okay, Gokul. Why is this YouTube not working here? Guys, are you able to see me in YouTube? Any problem with YouTube? Because I'm not getting responses in YouTube. Okay, just type in, okay, if everything's fine. Okay, chalo. Then the next one. The same question, all right? We have the same question with same lambda and mu. Okay, now do question number D. Okay, find the probability that a machinist does not have to wait for the service. Okay, yeah, Ankit, it's my privilege, all right, and please share this video if you can, make it viral. That will be really helpful to me and to my team, all right? Okay, that's what we want. Yes, good, guys, okay, and just keep on believing, guys, okay? And if you're not able to understand it, you can always go back to your rooms and, you can repeat the video. That's the beauty of online coaching, right, and online teaching. Isn't it? It gets recorded. That's the beauty. All right. And with practice, again and again and again, it will come to you. Don't worry about that. Okay. It always comes. Yes. So find the probability that machinist does not have to wait for the service. So what is that? What do we need to find? First, let's discuss about that. Okay. Yeah, so people are saying it's 0.533. Krishna has a different answer. Okay, fine. That is also fine. At least you are getting some answers, okay? So, what do we need to find? Yeah, thank you, Ankit, for that kind comment of yours. I really appreciate, okay? So, yes. So, what it is trying to say, probability that a system is idle. Idle means it's not working. It's not working means there's no one in the system, right? When there's no one in the system, then a machinist does not have to wait, isn't it? That equals to probability of 0 customers in the system. Customers in the system, that is nothing but P0, right? So that is nothing but P0, and that is 1 minus lambda upon mu. So can you please calculate this? So 1 minus, what is lambda? Lambda is 4 or 7? 7. 7, okay, I'm going to delete this. Alright, this is going to be 7 upon 15. So just calculate this, alright. Probability that system is idle. Probability of 0 customers in the system. 0 people in the system, right? Yeah, exactly. Practice makes a man perfect. So you just get back to home, revise this, guys, alright. Then only you will be able to understand it. Otherwise, it becomes really messy, okay? So how much are you getting? 0.533. 0.533. Is it good? Is it good? Yes? Could you understand this? If you could not, just go back home and repeat this video, okay? That's the beauty. I keep on telling you guys, okay, all right? That's why we should be doing these online lectures and classes. Chalo. Okay, good. Shubham says, practice makes man perfect. That is true. Should we proceed? Now the next one, E. I think this is clear, right? When there will be no customers in the system, no one in the system is idle, then only you can just go and you don't have to wait for the service. You are the one who is going to get the service, right? So what is E? Don't worry if you're not getting this. It will come, it always comes, okay? And let me tell you that these questions are not very easy, okay? They are not very easy. I have made them deliberately a bit tough. Okay, so let's see if you can do this. All right, so tell me now. So we are going to do E. Find the probability of minimum 7 machines or machinists in the system. So minimum they have to be 7 in the system, right? Maximum it can be anything. So what do you think about this? Can you please type in what do we need to calculate over here? Option E. Option E, all right? A bit tricky, is it? Okay. Just think about it. Probability of minimum 7. 7, 8, 9, 10 and so on. That's what it's asking for, Mohammed. Right? Minimum, yeah, exactly. Yeah, Gokul I think is right. Yes, Gokul, you are right, okay? Good, well done. Others, what do we need to find? Firstly, let's talk about that. Don't tell me the answer of this abruptly, all right? So let's talk about what we need to find. And this, okay, I'm going to stand here because, yeah. So what do you think it is? Minimum 6 people. Just think about it, guys, okay? We have some time over here. That's why I'm prompting you to think, otherwise just solving questions is not going to help you. Okay, so it says that probability of 7 machinists or probability of 8 machinists or probability of 9 machinists and so on is what? Yes, Ankit, I think that P7 should not be included, okay? Ankit, because P7 is already included here. Equals to 1 minus. Yesterday we have had a talk about this. P0 plus P1 plus P2 plus P3 up to P6. Minimum 7. So this is what it is. Right, Mahendra has already calculated it, 0.3904. Okay, good, Mahendra. So can you please calculate this? So what is P0? P0, you know what is P0. P0 we have already calculated it, 1 minus lambda upon mu. Lambda is given to you, mu is given to you, right? What is P1? P1 is nothing but rho to the power 1 into P0. Yes, and rho is nothing but lambda upon mu. Right, this is what I had told you yesterday. Yes, okay, now just write it like this. So lambda upon mu into P0 is 1 minus lambda upon mu. P1 is like that. Is it good? Yeah, Ankit, I hope that you realize your mistake, right? So 7 should not be included in that. Okay, similarly, P2 we can write, right? So P1 is like that and P2 is nothing but rho square into P0. And so on. P3 also can be written like that. P3 is nothing but rho cube into P0. Right? So please calculate this. Please calculate this. And tell me how much you are getting. You just need to calculate this one, alright? This is what you need to calculate. There are two ways to calculate it. First one is you just directly calculate everything, alright? Second thing, if you realize that it will make a geometric progression. Just a hint for you to solve it very quickly, alright? Yeah. So what's the answer? Mahendra has given his answer. And what's the answer for this? You're looking for an answer, right? So just tell me what is the answer. Okay, you're numb out there. ठीक है. Okay. So what I'm going to do is I'm going to just erase every one of this. Or maybe I can make one more like that. Okay, and let's talk about this. P0 plus P1 up to P6, right? This is what we were talking about. And P0 is P0. P1 is nothing but rho to the power 1 into P0, right? Plus rho square into P0, right? Plus rho cube into P0 and all the way up to rho to the power 6 into P0. Right? You just take P0 common. Okay, then 1 plus rho square plus rho cube rho to the power 6, right? Is it good? Yes, exactly. Yeah. So this is nothing but a G piece, okay? So what is the summation of a GP? A plus AR square until AR to the power N. Okay, so this is 0 to N minus 1, okay? So these are n terms, right? So this is written something like a into 1 minus r to the power n upon 1 minus r. Is it good? Yes. Yeah, so people are getting that 0.00427. Okay, fine. So because this is GP, all right, geometric progression. This is nothing but a GP. Is it good? Okay, then people are getting a bit confused over here. So, okay, so this thing, okay. Now I'm going to just write this thing over here, this over here. Okay, that is nothing but P0 into A. A is the first term in the series, that is 1. Okay, 1 minus, common ratio here is nothing but rho, right? This upon this is the common ratio here. If I divide this by this, I'm going to get R. Similarly, if I divide this by this, this by this, I'm going to get rho. So rho is the common ratio here. And how many terms are there? There are 7 terms out there, right? 1, 2, 3, 4, and so on up to 7 terms. So I'll be getting this and 1 minus rho. Are you getting this? Okay, are you getting that? If you can do it by binomial, well and good. And this one is another way, all right? So what is P0? P0 is nothing but 1 minus lambda upon mu. We had already calculated it, right? And rho is nothing but lambda upon mu. Can you please put in these values here and try to find, okay? And here in this case, lambda is nothing but 7, mu is nothing but 15. So that is nothing but 8 upon 15. 8 upon 15, all right? That is P0. Rho is nothing but lambda upon mu, that is 7 upon 15. Just plug in these values, guys, all right? Just plug in these values and tell me what are you getting, okay? Is it good? Is that good? Now, if you don't know geometric progression, you can go back and you can open any standard book, any book, 12th book, okay, 10 plus 2 book. I think you are going to get this, okay. The sum of a geometric series is given like this. Hello, how much are you getting? 0.9951, is that it? How much are you getting when you are putting these values, okay? I don't have a calculator, otherwise I would have done that, okay? But I want you to do it, okay? Because my job is to make you visualize a goal. Yes, okay. So this thing that you're getting is how much? 0.005. Okay, fine. Yeah, so 0.9951. Krishna Kumar says 0.9951. That's what you're getting. Okay, I believe that Krishna has done the correct calculations. All right, now 0.9951. Okay, this thing is 0.9951. So, this becomes 1 minus 0.9951, right? Yeah. So 0.00482. So 0.482 is your answer. I hope you got the concept, right? Obviously, you're going to calculate all of these things. Don't worry about the calculation part, but worry about this part. If this is clear, everything is clear, all right? Yes, so 0.00482, good guys, all right? Yeah. Yeah, Mohammed, you're also right, 0.0049, I'll take that. Okay, that's the probability of minimum 7 machinists in the system. I or an I, should we proceed? This is not very hi-fi stuff, guys, okay? This is just that, we have already discussed about it yesterday, that's all. Okay? Yeah. So should we proceed? Yes, good. What about YouTube, guys? There are many people in the app but not in YouTube. Just Ankit is there, okay, who has been a consistent student, and consistency, I say that it's very much required. Okay, then what about this one, F? What about F? Should you do F? So what do you need to calculate in F? Just type in, guys, okay? Just think about it and just type in. I want to see if you're getting this or not. Okay, so what do you need to calculate in F? So maximum 7 machinists, there can be 0 or there can be 1, probability of 2, right? And maximum 7, so this is P7. Is it good? Yes? Yeah, exactly. Krishna, you're good. Impressive again. Nice. So what is this value? Have we calculated it? Or we didn't calculate it? So similarly, okay, you can calculate this. Similarly, whatever we did there. Alright, so we did it till P6, alright, Krishna? We didn't do it till P7. Okay. Are you getting this? This one is till P6, whatever came over here, right? So it cannot be 0.9951. Okay? Mahindra, again, you need to check everything, all right? Yeah, so P0, P1, P2, P3, and I want you to calculate it the way we calculated it, okay? So can you please do that? Or just do one thing, because we already know that this thing we already know, right? This thing we already know, P0, P1, P2, P6, that's nothing but, how much? 0.9951, yes. So that's nothing but, this thing is 0.9971, 0.9951, all right. 0.9951, you just calculate this, right? And this is nothing but rho to the power 7 into P0, right? So just add them. Are you getting that? How much are you getting this? 9977. Good. Good, Shubham. Okay, yeah. That's nice. 0.99775. Yes? Yeah, good. 0.99775. Okay. So this is nothing but 0.99775. That's what is the probability. Okay? Is it good? Hello? Ankit, you're just being there. Okay, fine. It's good that at least you're hanging up, okay? Good that you're hanging up. Okay, chalo. I or an I. Could you understand this? Could you understand this? Okay, good. Now let's do this. G. What is the answer for G? And let me again tell you, these are not very easy questions, okay guys? These are tough questions. And if you are not able to get them, you will get them if you understand the theory part first, alright? Don't worry if you're not getting them at this point of time. Maybe you're in second year, third year, maybe final year, even. All you need to do is go back and revise it, repeat things, then things are going to happen. Okay, so what is the answer of G? How many maximum machinists can be accommodated in the crib? Now this is a tricky one. This is the tricky one, alright? ESE paper questions. Mohammed, no, actually, not exactly ESE paper, but just some of them are my own creations. Okay, chalo fir, let's do this. G. How many maximum machinists can be accommodated in the crib? Now tell me. Tell me, what do you think about this answer? This is a tricky one. You will never get this anywhere else. Alright, is it LS? Shubham, that's average number of people in the crib, right? I have written maximum machinists. So what's the answer for that? Yeah, Mohammed, actually, yes, my job is to, give you more questions that come directly from here, from my head, right? Yes, so what do you think about this? How many maximum machinists can be accommodated in the crib? No idea? Yeah, Krishna is correct. He has given an answer. Good, yeah, impressive again, Krishna. Okay, but just think about it, okay? I'm going to give you a hint. Just go back to the model definition that we had talked about. Just go back. Yesterday we talked about this thing, right? Something MM1, infinite, first in, first out, right? We wrote this thing. What we wrote? We said that this model is nothing but this. MM1, infinite, first in, first out, right? Now tell me, okay, I've given you an hint here. Yeah, Gokul, you're also right. I'm not going to tell the answers of Krishna and Gokul, alright? So, we are talking about option G, guys, alright? Now tell, by looking at this, now you can say it, right? Come on, come on, come on. You can do this. Just think about this. What are all these things over here? Tell us. Just think. Go back yesterday. Okay, this one is telling you that, okay, it's a Poisson's arrival distribution, okay? And this one is telling you that the service time is exponentially distributed, right? Yeah. So, and this one is telling you that, okay, there's just one counter, all right? And this one, infinite, is telling you that there can be infinite people in the system. So, yes, maximum machinist is nothing but infinite here. There's no limit to it. Okay, in this model, infinite people can be accommodated. Okay, that was the hint. Is that good? Do you agree or not? I or an I? Or should we proceed? Do you agree or not? This one is telling you that infinite number of people are allowed in this model, all right? Yes, Mohammed. But let me tell you again, these are not very easy questions, all right? These are tough questions. And you need to have a very strong grasp of theory to do these. If you're not able to do, just go back, revise the theory, then you're going to get that, okay? Good. Next one, H. What is that? H. Yeah, Krishna, you're right. Machinist, okay, not machine. Krishna, again, you're right. Good. Now think about this. How many maximum machinists can be serviced at a given time? Yeah, exactly. Mohammed, you have understood it now. Now you're getting that, okay? Good. Others, I'm looking for more options, guys. And like the session, share this video so that others might also be helpful. Others might also get some help, all right? Yes, Mohammed, you're right, okay? So, what do you think? Shrikesh, yes, you're also right. Shrikesh, all right? What about YouTube's? All the students from the app gave the exact answer, the correct answer. What about from YouTube? Any one correct answer? Or any one answer like that? Ankit, what about you? Yeah, Shubham, you're also right. I'm not going to reveal the answer right now, but yes, you're right. Okay, good. Ankit Srivastava, what is your answer? Again, let me give you a hint. Just look at this, okay? Just look at this, because this is the model that we are talking here. Right? Just think about it. Just think about it. It'll come, okay? It'll come. It always comes. Ankit, are you saying 15? No. Maximum I am saying, okay? Maximum machine is that can be serviced at a given time. Obviously that is 1, okay? This one is telling you that there's just one counter, right? So at a given point of time, just one can be serviced, right? So 1 has to be the answer. This is 1. Good. Good. Shubham, Shrikesh, Mohammed again, and Krishna, obviously, yes, is good. That's good to see you, right? Good to see all these responses. Okay? Is it good? Hello? Is it good? Should we proceed? 15. Okay, fine. Shubham, okay, fine, good. Krishna Ram also says okay. Okay. Fine. Is that good? Hello? Is it good? Now let's close this down, guys, okay? I think I have one more class tomorrow, and I'm going to see you again tomorrow at the same time. But yes, let me tell you that these questions were not... Okay, we'll take up this question if you meet tomorrow. I think we are going to meet tomorrow as well. It's the same time. And yes, Vision 2021, you can start a free trial. This is the second batch that we are starting, okay? And yes, if you believe that, we can take you there, we can give you that thought process as well as the concepts to succeed in any examination. Yes, you can join us, all right? And that is free. You can take a free trial and see it yourself if you want to continue or not, all right? And yes, we also have some cool discounts over here. And from my side, I say that, okay, just go back home, revise the things, and then again, come back, okay? Yeah, thank you, Mohammed, for tuning in. Thank you, Krishna. Shubham, you have been consistent. Thank you, Ankit, you have been consistent, okay? Okay, 47. Praveen. Yeah, it's fine, Praveen, all right? You can always have a look at this. Yeah, you can always have a look at this, okay? That's what it is. All right, today you took class at 7 p.m. 7 p.m.? Yes, 6:15. Shubham, actually 6:15 I had a class. Okay, that was for BARC Computer Science, Mechanical, okay? And yes, yeah, Praveen, okay, I'll see you again, and good that, you're still into this, okay? Because you're traveling. Good. So thank you, Krishna Ram. Again, I'll see you. All right. And yes, I think that I had given you something to think about. Okay. These were not general questions. Okay. You can also subscribe to the channel, guys, and share this video. Be happy. Keep on smiling. I'll catch you soon. Thank you very much.